Okay, in this video, we're learning how to calculate the molecular formula. So remember, it's all about me. Well, not me like Mrs. Herman, but me as in divide your molecular big divided by your empirical small. So let's get started. Using your POGO, you would see that example 1 was already completed, but we're going to go through the step-by-step process. An unknown compound has an empirical formula of CH2O with an experimental molar mass of 180 grams. What is the molecular formula for this molecule? So many moles in there. So the first step is to find the molar mass of your empirical. So if I find my empirical, that's the formula in the problem. I have CH2O. So C equals 1, H equals 2, and O equals 1. Then I'm going to times it by the bottom number in the periodic table, your molar mass, decimal to 2. So I have 12.01. We're going to have 12.01. Hydrogen's 1.01 times 2 gives me 2.02, and oxygen is 16. So now I have to add up 12.01, 2.02, and 16. So you might want to have a calculator handy to follow along with us. So I'm going to see that I get 30.03. Now that gives me my empirical. If you can't remember what the molecular or empirical is, remember you're going to divide your big by your small. So you're going to find your big in the problem of 180.0 grams. So we're going to have 180.0 grams here divided by our 30.03 here. And when we divide them, we're going to see we get 5.99. Can we round that reasonably to 6? Yes. So now we have to multiply the subscripts by that number. So originally we had C1H2O1, and we're going to multiply it by 6. So now I would have C6 and then H12, because 6 times 2 is 12, and O6. And we now have the molecular formula for our unknown compound there. So now let's try example number 2. So example number 2 says, what's the molecular formula if the empirical formula was NS with a molar mass of 184? So first you have to find the empirical molar mass. So we have to add up 1 N and 1 sulfur. So we're going to times it by 14.01. Where did I get that number? From the periodic table. So we have our 14.01 and 32.07. So we have our 32.07, a little mental math here. We're going to get our 46.08 as our empirical. If you can't remember what's molecular, what's empirical, remember we're going to do our big divided by our small. So we're going to have our 184 on the top is our molecular and our 46.08 as our empirical on the bottom. So this is where we need our calculator out. So in our calculator right now, we're going to plug in 184 divided by 46.08. We're going to see we get 3.99. Can I reasonably round that up? Yep, right to 4, but we're not done yet. We still have to multiply it by the subscript. So we had N1S1. If I distribute or multiply it across, I would end up with N4S4, and that would be the molecular formula for example number 2. Now, example number 3 says, what is the molecular formula for a compound that has an empirical formula of CH3 and a molar mass of 60? So we're going to find the empirical molar mass first. So C equals 1 times 12.01. That's 12.01. Then H equals 3 times 1.01. That's 3.03. And we're going to add it up and we get 15.04. So that's my empirical. So now we need to take our molecular mass. It's all about me, not Mrs. Herman, but molecular divided by empirical, or our big divided by our small. So we're going to see that we have 60.0 grams, our molecular on top, and our 15.04 empirical on the bottom. And when I divide these two, I see that I'm going to round it right to 4, but we're not done yet. Don't forget you have to multiply that by the subscripts number. So 4 times CH3, I would now have C4, and 4 times 3, I would now have 12. And so those are the steps that we go through to calculate the molecular formula. Thanks for watching.